As we have taken morphological structure of cotton and wool, today we are taking morphological structure or the morphology of silk. However, cotton and wool are having a very clear-cut morphological structure that is not found in silk, but we will take important things related with morphology of silk here. So first, the macro structure of silk. Silk is a very fine. Pardon? आवाज clear नहीं?
Not be shared yet.
Yes.
The screen has not been shared yet.
Share नहीं हो रहा है. Okay.
Sharing नहीं हुई अभी तक.
Now. अभी हो रहा है?
No sir.
Yes sir, अब हो गया.
Yes sir.
Okay. So I will repeat again. The macro structure of silk is a very fine, regular, translucent filament. This silk is a fine filament. Its structure is almost regular, and translucent means pardarsha. It may be up to 600 meter long, but averages about 300 meter in length. Most of the time the length is around 300, but it can extend up to 600 meter length. And diameter varies between 12 micron to 30 micron. This gives L/D ratio more than 2000:1. The important characteristic of silk for which it is known is the beauty and softness of silk's luster, and that is due to the triangular cross section of the silk filament. If we will see the cross section of silk filament in the next slide, the cross section of the silk filament is in triangular shape, and when we have the triangular shape of cross section, it gives good luster. So this beauty and softness, the reason of the silk's luster is its triangular cross section. Sometimes short questions may be asked. What is the reason of, or why the silk filaments or the silk textile materials are lustrous? It is due to its triangular cross section. As the silk filament is usually slightly twisted about itself, the angle of reflection of light changes continuously because slight twist is found in the silk filament. So due to this, angle of reflection changes, angle of reflection of light changes continuously. इसका रिजल्ट क्या होगा, इसका परिणाम क्या होगा? The intensity of reflected light is broken. तो उसकी जो intensity है वो break हो जाएगी, and that will result in a soft subdued luster. उससे क्या होगा, जो इसकी जो luster होगी, that will be, it will be soft and subdued. It will not be so intense. तो हमें देखने में भी अच्छा लगेगा. अगर बहुत ज्यादा intense है तो हमें देखने में pleasant feeling नहीं होगा. Its uneven and irregular surfaces are due to the coating of sarracen. जब तक sarracen का coating होगा तो surface regular नहीं होगी, surface uneven होगी और irregular होगी. After degumming, when we remove the sarracen part, it becomes regular filament. हो रहा है. Yes, microscopic view of mulberry silk. Here we are taking different uh, microscopic views for different silks that we will cover later, different type of silk. So the most popular type of silk is mulberry silk, and the silkworm is fed on mulberry leaves or leaves of mulberry tree. That's why this is known as mulberry silk. This is domesticated type of silk. So we are first taking microscopic view of domesticated or mulberry silk. So longitudinal view, LV means longitudinal view. And here you can see the longitudinal view shown in this diagram. It's a irregular elliptical ribbons, sometimes separate and sometimes twisted. No striations. Striations means the longitudinal lines. A number of lines are found in some of the fibers. In the longitudinal view of some of the fibers like viscose and this wild silk, some of these lines parallel to the length are found in the longitudinal view, and those lines are termed as striations. So, but here in case of mulberry silk, there is no striations found, and gum layer is not continuous. The sericin layer is not continuous. You can see in the diagram, कहीं-कहीं पर हमने जो dark space दिखाया, that is sericin part. So it is not a continuous phenomenon. Then cross-sectional view is shown here. It is like wave. Already we have taken the diagram of wave we have taken in the beginning of the lecture. These two are the fibroin and outside boundary. जो दिखाया उसके बीच में जो है that is sericin part. So it's a triangular, rounded corners. अंदर आप दोनों को देखेंगे. It is almost triangular shape but having rounded corners. In pairs, cemented by sericin or silk gum. हर एक के अंदर आप देखेंगे. These are in pairs and triangular cross section but rounded corners and cemented or joined by silk gum, that is known as sericin. If it is degummed silk, that was a raw silk, that diagram was indicating raw silk. Means when after drilling, whatever the silk we are getting, that this diagram is taken at that stage. Then degummed silk, longitudinal view is featureless. Here you can see the longitudinal view. No feature is there, a continuous, a simple structure is there. So we can say longitudinal view of this one is featureless longitudinal view. No specific features are found. And cross-sectional view is triangular cross-section. And after degumming, you can see they are not in pairs, only triangular and separated. Third one is wild silk. That we will take types of silk, then you will be able to understand what is wild silk. So one example of wild silk we are taking, that is a popular example of wild silk known as tussar silk. In the market also you have heard the word tussar. Tussar is the fabric made from tussar silk. So longitudinal view, flat, irregular, it is shown here, flat, irregular ribbons, sometimes separate, sometimes twisted, and with longitudinal striations. These are known as striations. ये जो lines इसके अंदर दिखाई गई हैं, 4-5 लाइंस बाउंड्री के अंदर जो दिखा रहे हैं, इनको हम इन लाइंस को हम स्ट्रिएशंस बोलते हैं, जो कि वाइल्ड सिल्क में भी होता है, टसर सिल्क में होता है, और दिस इज आल्सो कैरेक्टरिस्टिक आइडेंटिफिकेशन ऑफ विस्कोस. विस्कोस इज आल्सो हैविंग स्ट्रिएशंस. And cross-sectional view is very elongated, triangular, normally separate with rounded corners, like this. So these are the three types of microscopic view we have taken: longitudinal and cross-sectional view of mulberry silk, that is domesticated silk at raw stage, then after gumming, degummed silk, and wild silk. The characteristic microscopic appearance is due to the slit. हाँ, ये microscopic view जो आप में दिख रहा है, triangular cross section. Why it is triangular? The reason is here. Sometimes it may be asked why the cross section of silk filament is triangular cross section. Then you can answer, the characteristic microscopic appearance is due to the slit-like opening of the silk secreting glands. जहाँ से ये glands जो liquid secrete कर रही हैं, वो जो जहां जिस पार्ट से वो बाहर निकल रहा है, इट इज हैविंग स्लिट लाइक ओपनिंग. स्लिट एक ट्रायंगुलर स्लिट तरह की ट्रायंगुलर स्लिट जैसा ओपनिंग होता है, उसकी वजह से सिल्क का जो ट्रायंगुलर क्रॉस सेक्शन होता है, वन ईच बीइंग लोकेटेड ऑन ईदर साइड विद इन द माउथ ऑफ द सिल्क लार्वा. जो सिल्क वॉर्म है उसके मुंह के अंदर की तरफ दोनों साइड्स के अंदर स्लिट लाइक ओपनिंग होती है, और वो जो स्लिट लाइक ओपनिंग उनका शेप ट्रायंगुलर शेप होता है. दैट्स व्हाई the silk filament is having triangular cross section. The microstructure, yeah, this is all about microscopic view of silk filament, different type of silk. So we have taken macrostructure, then microscopic view. Now we are taking microstructure of silk. The silk filament is a fine coagulated stream of fibrin solution. Coagulated means a solid state. When liquid converts into solid state, that is known as coagulation. The silk filament is a fine, it gets solidified when comes out of the slit-like opening. So coagulated stream of fibrin solution. Fibrin means protein of the silk, and has no identifiable microstructure. इसका जो microstructure है बहुत specific या identifiable नहीं है, जैसा कि wool और cotton के केस में है. Fibrin is the name or the chemical for the protein which constitutes silk. I have already shared so many times. Fibrin is the name of the protein which is found in silk filament. Or you can say it's the name of the polymer of cotton, silk filament. Just like cellulose is the name of polymer of cotton, keratin is the name of the polymer of wool, fibrin is the name of the polymer of silk. Now, something about the polymer of silk. The silk polymer is a linear fibrin polymer. A few things about the polymer. First is, silk is composed of 16 different amino acids. Like wool is composed of 18 different type of amino acids. Silk is composed of 16 different type of amino acids. Some are common with the wool and some are different from wool. 3 of these 16 amino acids, in 16 में से 3 क्या क्या नाम है? एलेनाइन, ग्लाइसिन एंड सेरीन. ये इंपॉर्टेंट एमिनो एसिड्स हैं जो कि सिल्क में पाए जाते हैं. मेकअप अबाउट 80% ऑफ सिल्क पॉलीमर्स कंपोजिशन. सिल्क का जो कंपोजिशन है उसका 80% पार्ट इन 3 से होता है. बाकी सारे जो 13 बच रहे हैं, दे आर फॉर्मिंग 20% ऑफ सिल्क पॉलीमर्स. सो मेन डोमिनेटिंग this amino acids found in silk are alanine, glycine, and serine. So sometimes short questions may be asked on this. Name the amino acids found in silk or name the important amino acids found in wool. And in both the cases, you can see different type of amino acids are found in wool as well as silk. So you have to remember the name. The silk polymers are not composed of any amino acids containing sulfur. That is the major difference between wool and silk. Wool contains amino acids which are having sulfur content, but in silk, no amino acids is found which is having sulfur content. Hence, the polymer system doesn't contain any disulfide bonds. और इसीलिए इसके अंदर कोई disulfide bond या covalent bonds नहीं होते हैं जो कि wool में होते हैं. That is one of the major difference between wool and silk. Disulfide bonds are not formed in silk, which are formed in wool. Reason is amino acids found in silk. There is no amino acid in the silk which is containing sulfur. अगर सल्फर होगा तभी डाइसल्फाइड बॉन्ड बनेंगे जिनको हम कोवलेंट बॉन्ड बोलते हैं. The silk polymer occurs only in the beta configuration. वूल के अंदर कौन सा कॉन्फ़िगरेशन था? अल्फा कॉन्फ़िगरेशन. हियर बीटा कॉन्फ़िगरेशन. बीटा कॉन्फ़िगरेशन कैसा होता है वो हम नेक्स्ट स्लाइड में देखते हैं. The silk polymer is about 140. Yes.
सर वही 5th स्लाइड फिर से बताओगे? मैं समझा नहीं बिल्कुल, और आवाज बार बार बफर होते जा रहा है.
This one. This slide.
हाँ, 5th स्लाइड. यस सर, वो वापस बताओगे ट्रायंगुलर कैसे? यस, वापस बताओ सर कि ट्रायंगुलर कैसे वो फॉर्म हुआ?
It is the shape of the slit from which this liquid is secreted. जो ग्लैंड्स जो अंदर की तरफ है जहां से लिक्विड सेक्रीट हो रहा है उसका जो शेप है स्लिट लाइक शेप दैट इज ऑफ ट्रायंगुलर शेप. तो वो ट्रायंगुलर शेप होने की वजह से जो सिल्क फिलामेंट मिलेगा हमें उसका क्रॉस सेक्शन ट्रायंगुलर होगा. इज इट क्लियर?
Yes. So, और ये
I have to repeat whole slide or only this was your question?
repeat the whole slide now.
The silk filament is a fine coagulated stream of fibroin solution and has no identifiable microstructure. Fibroin is the name for the protein which constitutes silk. Clear है यहाँ तक? Now something about silk polymer. The main 3 points we are covering here. Silk is composed of 16 different amino acids. Just like wool contains 18 different amino acids, silk contains 16 different amino acids. और उन 16 में जो 80% part है, that is covered by alanine, glycine and serine. These are the 3 amino acids dominating in silk polymer. Second point is the silk polymers are not composed of any amino acids containing sulfur. That is very important because if sulfur is there, then disulfide bonds will be formed, which is found in wool fiber. Here sulfur is absent and that's why disulfide bonds are not formed in case of silk. Clear? And the third one is silk polymer occurs only in the beta configuration. The polymer structure is in the form of beta configuration. And what is beta configuration, that I will take in coming slides. The silk polymer is about 140 nanometer long and about 0.9 nanometer thick. The repeating unit of silk is the amino acid. Same as wool. Wool and silk both are amide fibers, polyamide fibers. So amino acid is the repeating unit. Name of the monomer is amino acid. And name of polymer in case of wool is keratin. And in case of silk is fibroin. Both are different type of proteins. The important chemical grouping of the silk polymer are the peptide groups, जो कि wool में भी होता है, and which give rise to hydrogen bonds. These peptide groups are resulting in formation of hydrogen bonds, and the carboxyl and amine groups, amino groups, give rise to the salt linkages, ionic bonds. So hydrogen bonds and ionic bonds or salt linkages are the main interpolymer forces of attraction found in silk filament. Van der Waals forces are always there in almost all the fibers are having van der Waals forces, but covalent bonds are absent in silk, which are found in wool fiber. So that was about polymer. Now what something about polymer system. So here we will study about the polymer system of silk filament. It's a linear fibroin polymers are considered to be arranged in folded or beta configuration. ये beta configuration को हम folded configuration भी बोलते हैं, and it looks like this. It is arranged like this in M shape. So if this type of structure is there, it is known as beta configuration. If helical structure is there, that is known as alpha configuration. So the polymers are arranged in wool in alpha configuration and in silk in beta configuration. And that's why much differences in the properties of wool and silk is there. And because it is beta configuration, it provides us very crystalline polymer system. About 65 to 75% crystalline and respectively 35 to 25% amorphous. So it is considered as a highly crystalline fiber. The major force of attraction between silk polymers is hydrogen bonds. Fibroin polymer must lie closer together than 0.5 nanometer distance. Only then hydrogen bonds will form. Now the chemical composition of silk. And silk mainly consists of two portions, fibroin and sericin. Sorry. The fibroin is the silk fiber which is usually coated with sericin. That already we have.
Major attraction.
The fibroin is a silk fiber which
Hello?
is. बेटा ऐसे बार बार अगर आप बार बार डिस्टर्ब करेंगे मैं अपनी क्लास में अलाउ नहीं करूंगा आपको. If you have any question, you can ask at the end.
नहीं
Just
सर. Okay सर.
join is there.
हाँ.
Join is a silk fiber which is usually coated with sericin. Different chemicals in the silk. We are taking different type of silks: mulberry silk, tussar silk, muga silk, and eri silk. इनके बारे में डिटेल्स हम नेक्स्ट क्लास में करेंगे. What is mulberry silk, what is tussar, what is muga, and what is eri silk. Here just these different type of silks. This is domesticated silk. Mulberry is the only silk which is domesticated. Tussar, muga, and eri comes under wild silk. So they have difference in the percentage of fibroin, sericin, and other materials. So fibroin in mulberry silk is 70 to 80%. Tussar is 80 to 90%. Muga is 80 to 90%, and eri is having 80 to 90%. So means all the wild silk are having 80 to 90% fibroin, whereas mulberry is having 70 to 80% fibroin. Sericin is here 20 to 30%, and in this case 8 to 10%, 8 to 10%, and in eri 4 to 5%. And other materials are 2 to 3, 3 to 5, 3 to 5, and 3 to 5. And other parts consist of waxy matter, carbohydrates, mineral matter, and coloring matter. The yellow coloring of silk is due to the coloring matter present on the mulberry leaves. And chlorophyll is the green coloring matter in green silk. Sometimes we found green silks also. So chlorophyll is there. If chlorophyll is found in that one, then it will give green color to the silk materials or silk filament. Chemical composition of fibroin and sericin. अब हमने लिया पहले chemical composition of silk. Now we are taking separately chemical composition of fibroin and sericin. So fibroin इनमें जो content है that is carbon, hydrogen, nitrogen, oxygen are found. कार्बन का परसेंटेज फिब्रोइन में 47.6 है, सेरिसिन में 46.5, हाइड्रोजन फिब्रोइन में 6.4, सेरिसिन में 6, नाइट्रोजन 18.3, 16.5 in sericin, and oxygen 27.7 in fibroin, whereas 31% in sericin. The fibroin is made up of series of different amino acids. Already we have covered. The structure is generally a polypeptide structure. The most important amino acids are glycine 36.8%, highest percentage of amino acid, that is name of amino acid is glycine. Then alanine at the second position 22.2%, serine is 11.4%, and tyrosine at 11.1%. And that's all about this morphological structure, microscopic view, and chemical composition of fibroin and sericin. So still we have 6-7 minutes. So if you have any question, we can go through that. Otherwise, we can cover also the different type of silks. If you do not have any question, we can go through this one also.
Sir,
Yes.
sir, beta arrangement, please once again. Beta arrangement.
The arrangement. Okay.
Beta arrangement.
Better if we have 6 minutes, and if I can complete this one in the next class, we will repeat the beta configuration, and even I will repeat the whole topic of silk. Okay.
Okay, sir.
Yeah. So here we will try to cover it fast, and then I will share the video so you can go through the content also. So because much theory is there, two types of silk: domesticated and wild. Domesticated silk can be cultivated and manufactured for textile purposes. On the other hand, wild silk can be produced from uncultivated caterpillars. First क्या है, जिसको हम cultivation कर रहे हैं, that is known as domesticated. और जो हम cultivation नहीं कर रहे हैं, automatically जो nature में बन रहा है, that is wild silk. Domesticated silk comes from the genus Bombyx. तो ये जो प्रजाति हैं, जहाँ से हमें domesticated silk मिल रहा है, उसका नाम है Bombyx. The principal species of which is Bombyx mori. और उसकी जो main जो species है, जिससे हम silk filament लेते हैं, that is named as Bombyx mori. And this is the worm that feeds. Bombyx mori is the name of the worm which feeds on the leaves of mulberry trees. So, and this silk is also known as mulberry silk. तो बॉम्बिक्स मॉरी सिल्क बोल सकते हैं या इसको आप मलबरी सिल्क बोल सकते हैं. मलबरी हम इसलिए बोल रहे हैं क्योंकि ये फीड करता है मलबरी लीव्स के ऊपर. So silk industry can be mainly classified into mulberry and non-mulberry. The non-mulberry or wild silk consist of tussar, ari, and muga silks. Out of these 4 varieties, the mulberry silk accounts for 80% of nation's total production. Something about the silk. Mulberry, as the name indicates, are produced by worms, Bombyx mori, which feed on mulberry leaves. ये हमने पहले लिया. Most gorgeous and fabulous silk materials are produced out of this variety. It is the best quality of silk. The major states that produce raw domesticated silk are Karnataka, Andhra, Tamil Nadu, Bengal, Assam, J&K, UP, Manipur, and Bihar. Then Ari silk. It is from Attacus resin, just like Bombyx mori is the name of species of mulberry silk. Worm, name of the worm. Similarly, Attacus resin is the name of the worm from which we are found getting Ari silk. It feeds on the castor leaves. ये मलबरी पे नहीं होगा, ये कैस्टर प्लांट की लीव्स को खा के ग्रो करता है. मेजर सोर्सेज ऑफ एरी सिल्क आर, जो स्टेट्स हैं वो असम, मेघालय, मणिपुर एंड मिजोरम. टसर सिल्क, दिस कैन बी ऑब्टेन्ड फ्रॉम द जीनस एंथीरिया और अटेकस. Indian tussar silks are obtained from the moth Antheria melita. It feeds on the leaves of sal, Assam, Arjun, bear, or pool, which is available in Bihar, Odisha, MP, and Bengal. Clothings of this variety have subdued luster. Means एक तो हम यहाँ कवर कर रहे हैं किस प्रजाति से हमें मिल रहा है. सेकेंडली भी हम कवर कर रहे हैं कि वो किस तरह की प्लांट्स पर फीड करता है. एंड थर्ड, कौन कौन सी स्टेट्स में मिलता है. Muga silk is obtained from Antheria asama. This worm feeds on the leaves of sum and huelin, which is available in Assam and produces a golden yellow silk. So this is also known as golden silk. And these are the differences between these 2 types of silks: domesticated, also known as mulberry; wild, also known as non-mulberry. So first difference is domesticated or mulberry silk is commercially valuable, having high cost, whereas non-mulberry or wild silk is less valuable. Here the silkworm is Bombyx mori, here tussar, Antheria melita, muga, Antheria asama, Ari, Attacus resin. Silkworm feeds on mulberry leaves. A silkworm of tussar feeds on leaves of sal, Assam, Arjun kul, muga, leaves of sum and huelin, Ari, castor leaves. ये हमने पहले ही कवर किया, उन्हीं को हम पॉइंट वाइज अलग किया. Cultivated, this domesticated silk is cultivated under controlled condition and produces the highest quality of silks. It is not controlled, usually give a stronger, more alkali resistant silk. Fifth one is continuous or more or less uniform filament. Here short length, non-uniform filament or fiber. Less impurities because of formation of cocoon in magnaneries in fresh and clean environment. This contains more impurities. Here we are getting finer filaments. Here we are getting thicker filaments or coarser filaments. Domesticated silk is more lustrous, whereas wild silk is less lustrous. Domesticated silk is less resistant to moisture, whereas it is more resistant to moisture. This is more expensive. This is more cheaper. So this is all about these 2 types of silk, domesticated and wild silk. So don't get confused when the question is asked in the examination, different type of silk. Explain different type of silk. It means your answer will be this domesticated and wild silk. But if it is asked, explain different type of silk filament yarns, silk yarns, then हम उसमें वो कवर करेंगे जो कि हमने थ्रोन सिल्क yarn जो लिए थे different varieties, वो आंसर होगा. तो सिल्क yarn और सिल्क के बारे में पूछा जाए उसके अकॉर्डिंग आपको आंसर करना है. So this is all about this one, and only one thing is remaining in this topic is physical and chemical properties. So in the next class, we will cover, first we will revise all that we have done so far related with silk with your questions, answers, and then we will move to the next topic, that is physical and chemical properties of wool and silk.